Excellent. Thank you so much for that. Next up, the mystery of Mount Diablo. Danik and Micah.
Okay, so our presentation was on the mystery of Mount Diablo. So Mount Diablo is a mountain that we visited for our like a field trip, I guess. It's like an hour and a half drive from here. It's really good views if you look on the bottom left photo there. Something that's interesting about it is that on the peak of it, it contains a lot of rocks from the Franciscan complex. So if you look at where it says peak, the purple stuff around that is serpentinite, and the orangish brownish stuff next to that is basalt. But to figure out more interesting stuff about the mountain, we need to learn about what? I swear.
On. Yep. We're still resume share. Please.
Do we have to open up tab?
What's that? Window. Okay, so we can see it. Can you still see it, Lauren?
Yeah.
Okay.
Okay.
Okay, superposition is a common principle of geology. And what it is that it's the idea that the older rock will be on the bottom of, the older rock will be found on the bottom and the younger rock will be found on the top, because as rocks build on top of each other, the newer layers are built on top of the older layers. However, there is one place we know that doesn't follow this rule of geology.
And if you can guess, that place is Mount Diablo. The reason it doesn't follow the principle is because the oldest rocks are actually on the top, while the younger rocks lay near to the bottom. So
in order to figure out why this happens, we have to find out the age of the rocks on the mountain. As Danik said, on the peak of Mount Diablo, there's Franciscan formation rocks and older oceanic rocks. And the fossils nearby found on the mountain can be used to determine the age of the rocks elsewhere.
So there is a blind fault or blind thrust fault under Mount Diablo. And there's a theory about how it was formed, where the fault underneath it pushed upwards, making the mountain rise and causing a mound to form. In the simplified animation, what do I do for this? Should I
Just enable.
yeah.
Okay, so here's a diagram of the blind thrust fault. And as you can see on the left side, there are layers that correlate with the right layers. But on the left side, the layers are slightly above the layers on the right. This can look weird because as you can see, there's older rock above the younger rock, but generally above it, there is still sediment that includes younger rock above the older rock. So that diagram, if you take the top of that diagram, and if you take this part of the diagram and you look at it, it could look like this, with the youngest rock layer on the outside and the oldest rock layer in the center. If you erode a large part of the mountain, it can look like this, where the youngest layers are still on the outside and the oldest layers are still in the middle. But this time you can walk on top of the layers and see them, as the oldest layer is close to the peak of the mountain. Combining this theory with the theory that there is a thrust fault, the oldest the oldest layer will be pushed upwards and above all the other layers, which is the supported theory that we have.
So although the story makes sense, it's not yet complete. Geologists are still trying to figure out all the history of the mountain. An example of this is if you look at the rock map in the top right, that map was made in September of 2021. So that's just an example that like we're still trying to learn more about the mountain and learn more about the history of it. So yeah, thank you.
Thank you, John.